Hello everyone and welcome from RoadRunner ONT. Today we are going live from Formula Student Poland. They are first, they are the fastest and they are the loudest.
The name for Formula One came because the teams, the motorsport companies, they were looking for the best formula, the recipe to create the car number one, right? The best car. And this is what these incredible minds, innovators and students, engineers are doing here. They're building cars day after day, night after night.
Student teams from around the world build their own designs of racing cars, which they race on the track. But to participate in these dynamic competitions, they must pass rigorous stages of technical inspection. And what is most valuable to them is feedback. Did they do what they did well? Does it even make sense from the perspective of how the industry perceives it?
I cannot imagine how incredible it feels for them to have been working years on a car and then see it on the track actually running. So I think the emotions today are going to be running super high.
These students had an absolutely incredible blast being able to finally end the season with a truly fantastic performance, and they really showed off on that track. On one hand, there was the competition regarding times, but we also saw that they were really enjoying themselves in terms of the overall execution.
Make your dreams come true in motorsport. Formula Student Poland, where the future of motorsport is born.
video created by one of our customers. Yes, it's real. So in developing its most advanced simulation center, as you see, the BMW company uses the RoadRunner environment to create scenes. Then they are exported to in-house simulation software called Spider that also integrates somehow with MATLAB and Simulink. But why do I bring this up? Because our topic today is RoadRunner 3D scenes and scenarios used in developing driving applications and testing and verification systems. My name is Mateusz Łabęcki. I work as the application engineering team lead at ONT, which is authorized MathWorks reseller for Poland. On a daily basis, I deal with signal and data processing in MATLAB and model-based design methodology based on Simulink. I'm mainly responsible for a HDL code generation toolchain and obviously the RoadRunner environment, which is our headliner today. So to begin with, let's mention some industry trends that are driving our recent investments in virtual scenarios. So first, a primary trend is the need to leverage simulation for early design and test. This is especially true in the context of closed-loop systems that need to take into account vehicle dynamics. Engineers want to reduce the amount of time spent for physical testing in the vehicle. Second trend we see is that there are many different driving simulations and driving simulation tools on the market today, both commercial and open source. All of them can be used during the design and testing process. The ASAM organization has been working to make it easier to interoperate between driving simulation tools with standards called OpenDrive or OpenScenario. Another trend is that to maximize simulation value, the scenarios under test must be representatives of real-world scenarios. What does it mean? We see a lot of companies working on taking logs from the recorded data and building equivalent virtual scenarios for the simulation. And we have answer using our tools for every of these trends. Today, in this presentation, we will discuss the value of virtual scenes and scenarios, and I'm going to introduce our RoadRunner tool that integrates with common driving simulation tools, and also, of course, MATLAB and Simulink. I am also going to show some example applications from industry and from Formula Student competition. My friend Kuba later will tell you more about building and simulating vehicle dynamics model in the next presentation. So here I presented the basic layers of driving application ecosystem combined with the corresponding MathWorks tool. So speaking of algorithm, we basically mean control systems, detection, localization, tracking system, every task related to the position of our vehicle, and perception systems. On the right side, we can see some code generation tools that allows us to generate the code from designed algorithm created in MATLAB and Simulink, so there's no need to write the code by hand. On the top main right side, I've included some code analysis tools called polyspace, so tools that are being used for static C or C++ code analysis, both handwritten code and generated code. And now let's focus on RoadRunner tool, RoadRunner product family, which is a graphical editor that serves us primarily for the first two steps highlighted on the screen, that is designing a virtual environment for simulation needs and test. So now let's compare the application called Driving Scenario Designer from MATLAB with RoadRunner tool. Scenario Designer is an interactive app from Automated Driving Toolbox and allows us to design simple road networks with intersections, some basic elements like walls or traffic barriers. In terms of scenarios, we can create them manually by selecting coordinates, and the actors are interpreted as cuboid objects. On the other hand, RoadRunner tool can consist of advanced state machines and logical expressions, lines, actors, some lane following behaviors, and all these scenarios are presented in photorealistic reality with high level of fidelity. Someone may ask, what's the main purpose? As you can see, there is a timeline. Automotive engineers need a virtual world with lots of details to obtain a credible environment for realistic situations and road traffic. But here, in the case of collision, there is only some error message or pop-up without incurring losses or sacrificing people's health. And another flagship example of our tool, this is one of the most recognizable roundabouts in the world, and it's copy made in RoadRunner. So RoadRunner scenes can not only be some single elements, but also a huge areas like big cities with road networks and buildings or highways. And keeping these elements in mind, now I'm going to explain RoadRunner products in more technical details. So, this environment lets you design a road network that can include intersections, highways, urban buildings, terrain, programmable traffic lights. All these things can be controlled using dimensions, cross-sections, lanes, angles, etc., numerical values. And RoadRunner can have a double role. Due to its independence, it is used by engineers working in external simulators and physics engines, but of course for MATLAB and Simulink needs. The automated driving toolbox from MATLAB serves as the interface between both environments, and we can use specific features from MATLAB like functions, system objects, or Simulink blocks to interoperate between these programs. And I will now demonstrate basic RoadRunner user interface using the short video. In the upper section, we've got the main toolbar, where the features and tools are divided according to specific functionalities. There is working area with the grid in the central section. At the bottom, we can see some extra views, library browser with all the files like additional assets or props. The attributes panel is located in the window on the right side. There you can configure all the parameters, numerical values, and dimensions. And importantly, you can perform all the actions using drag and drop technique, and with addition of some keyboard shortcuts, these features make the RoadRunner a really user-friendly tool. RoadRunner also ships some scene templates, which makes it easier to build scenes. In addition to this, you can also make templates from your selection, your asset, for the entire scene. You can also snap templates to form a new scene in a quick and easy way. Now I will explain the data flow, so import and export possibilities, and all the additional products like add-ons, something similar to MATLAB Simulink toolboxes. The first one, RoadRunner Asset Library, it's nothing but a library of elements like road signs, 3D objects, graphics, textures, etc., etc. Now let's talk about some import capabilities. We can import scenes and maps from ASAM OpenDrive files for versions from 1.4 to 1.7, which is currently a common standard in describing scenes and scenarios, especially for automated driving or ADAS systems. In addition to this, we can import OpenStreetMap, OpenCRG files, which is responsible for the shaping of road surface. What's interesting, RoadCRG tool is used by BMW company to edit and create CRG files, which are then later applied to tests of dynamic properties of vehicles, especially the suspension systems and chassis system. As the maps are also supported, these are low-resolution maps, so we can import them from different formats. It's also possible to import GIS files, so files including some geographic information built in. And another powerful tool called Scene Builder allows us to import and instantly convert high-resolution maps from different vendors to RoadRunner representation. As you can see, we can use here HD Live maps, TomTom HD Live maps, Apollo HD maps. So it can be said it provides some kind of interface between these maps and our environment. So let's assume we've just created the scene and it's time for export and practical use. We can export to OpenDrive files again. We can use some 3D formats like AutoCAD, FBX, STL, so well-known formats, but also we can choose to export the one of physics engine like Unity, Unreal, Carla Simulator, and later we can run it in external software seamlessly. And last but not least, we can run our scene with the RoadRunner scenario, which is a dynamic scenarios editor. It's the most recent add-on, which offers extra capabilities compared to the base products. So, remember this slide. Now on the slide we can see a complete flow diagram including import, export, all four products highlighted with the blue color in one data flow diagram. Let's now discuss the GIS files. Someone may ask how the GIS files are handled in RoadRunner and why do we need them? The answer is simple. After we put them on the grid for a building scene, we literally obtain a template. So we exactly see where are the edges of the road, lines, their shape, distances, and so on. For example, you can import the racing track and use it as a reference for building your digital representation for MATLAB and Simulink needs. And now let's take a look on the short video. Yes, so we can use this scene as a template. And what's more, whenever we have a digital elevation model, it's possible to embed our flat surface on it just by clicking one button. So then the scene will be arranged itself according to the imported altitude. Okay, now it's time to the Next add-on, so RoadRunner scenario. I'm also going to use a quick video. The RoadRunner scenario with similar user interface to base RoadRunner product allows us to create dynamic scenarios to simulate and test a vehicle in motion. It gives you the possibility to place vehicles inside the ready scene, including trajectories and the movement. And you can also define the vehicle behavior in something similar to state machines. Yeah? So behavior logic model, which we can parameterize. We can also define this behavior using built-in MATLAB and Simulink functions. Programmatic interface is also something what's available to users. And what does it mean for the scenes and scenarios? Well, dedicated MATLAB functions to generate, simulate, export, import, etc. If you want to use other languages than MATLAB, such as C++ or Python, go on, feel free. It's possible through the gRPC framework, which is a popular API for client and server communication between desktop applications. Oh, now something what's related directly to your topic. All these features that I've presented allowed dynamic PRC Formula student team from Polytechnic University of Milan to create a complete driver-in-the-loop simulator. So dynamics and control were implemented with MATLAB and Simulink, and the racetrack was designed with RoadRunner environment. You can read more from the attached link, but now let me present a short part of their story.
This is literally a driver driving our car in a Formula Student track. So we've been developing the physics of the model, the graphics, the pose position, the custom scenery, the sounds, the custom HUD, everything is custom and done by the team. This is very useful in order to simulate the car, to literally drive it and feel the car while it is still being built or while some development are required. In addition, we also added light.
So that's the short part of the story. You can read more and find the information using the website. And MathWorks as a company has been supporting student competition for many years, and Formula Student is among them. You can find us as on-site partners, for example, like here today, but also as a series of webinars and materials called MATLAB and Simulink Racing Lunch. We can also provide specific trainings and software for those of you who are interested. So if you want to know more details, feel free, come to our place and let's make a discussion. Okay, so coming back to real applications. Imagine a situation in which we have just designed a nice scene and a complicated scenario with some logic. It can be exported and our job is done. But we can go a step further. In this situation, we can read the data, for example, the ones presented on the slide, then pre-process it using external software like MATLAB and Unreal, and then control the ego vehicle under test in a closed-loop system. Basically, Simulink model can be a center of this process. This particular model consists of complete vehicle dynamics, control system, sensor data preprocessing. But me personally, I'm going to focus on 3D environment part, which includes RoadRunner scene used in simulation environment based on Unreal Engine. Co-simulation between these tools allows us to take advantage of every single one. For example, easy scene and scenario creation in RoadRunner, Unreal Engine, physics, reliability, and Simulink design and simulation versatility. So now let's investigate the component responsible for visualization. To configure a simulation 3D engine, you simply need one block to configure a scene source and a few extra blocks to control the vehicle visualization and sensor to measure necessary values and receive them as a feedback from the simulation. You can choose between few default MATLAB scenes, RoadRunner, or independent Unreal Engine executable files. All these blocks comes from MATLAB toolboxes related to driving and developing vehicles like Vehicle Dynamics block set or Automated Driving Toolbox. As a result, after the simulation run, you can access all the important measurements and monitor the vehicle behavior. Photorealistic visualization makes the investigation easier to interpret, easier than to analyze the data, and what's most important, without need to build the physical prototype on early stage of development, which reduces costs, risk, and of course, time. So earlier, I've mentioned the driver simulation, driving in the loop simulation created by Dynamic PRC team. Similar example can be done using the real-time computer that allows us to have a great numerical performance, what is hard to receive using the normal PC, of course, due to hardware limitations. Vehicle dynamics and control is deployed on SpeedGoat machine using the Simulink real-time add-on. Driver input comes from the Logitech steering, like gaming steering wheel, and the visualization is launched on the host computer. Using real-time devices is a common approach in automotive and other industries like aerospace or energy, especially for hardware-in-the-loop testing and rapid control prototyping. And let's now see a quick demonstration video. So as you can see, it's real and it works. And coming to the end of the presentation, for those of you who would like to learn more about RoadRunner environment, there is a free course material available on the MathWorks website where you can find some basic functionalities in easy way based on recordings and live instructions. You can go a step further, what I highly recommend. It's a training called Designing 3D Scenes and Scenarios with RoadRunner, which is a 2-day course providing almost all the knowledge and best practices on this topic. On the slide, you can see a course outline with areas covered during the course. And finally, I'd like to thank you for taking part in this presentation. If you have any questions, feel free to ask them now. Okay, so once again, thank you, and I wish you good luck in the next stages of your competition. And after a few minutes break, I'm going to give the floor to my friend Kuba.
well, you maybe feel free to use many even third-party toolbox, open source tools. So we are in the way to standardize it fully, as my colleague said. And in the end, of course, your model will be worth nothing when it wouldn't apply to the real situations, to real environment. So that may be captured by the third point. So as you've seen last, all of those capabilities are already provided by MathWorks tools. I will focus now on simulation, the driving applications, especially modeling physical objects. Here we can say a car. So what we can do in our tools? First, we've got several templates, libraries, guidelines, so you're not alone with your knowledge. You may choose already prepared solutions from MathWorks. Then you may integrate with the external softwares to make more deeper studies. You may author your own things, you already know it, for example, you know, RoadRunner. Then, of course, you've got plenty amount of data sets, and what you can do with that. You can analyze these data, and these analyses may be also automatical. You may use even deep learning methods to get some insights which shouldn't be visible on the first look. And in the end, you may deploy your model on your hardware target to make your hill tests, to make your digital app, or on your own controller. So this is capable by MathWorks coders, by Simulink coder, but by embedded coder, by Simulink real time, and so on. And in today's speech, I will focus on creating vehicles. So what we will capable today, I want to show you how to quickly generate your model, and then when you have the generic model, how to customize it to your purpose. And then that's not the end, because MathWorks has some tools to enhance the collaboration over the model. So you needn't to work on the separate models. You may cooperate with ease by using MATLAB projects. And in the end, of course, how to simulate that model. So, when we talking about modeling, it is trying to capture some real things to the mathematical language. It may be very easy, like when you have your vehicle and you want to know what is the gravity force. You may just multiply it to the gravity acceleration factor, and you're done. So model may be simple, but then you may see that the reality is not so simple at every time. So there are some drag forces coming from the vehicle speed. It may vary over the time. So you need to go for more complex approaches, such as ODDEs, DDEs, and some implicit functions. So it may be the implicit approach, but it will be worth nothing if it will do not be so tight to your real object. So the point is that you will get the several sets of parameters, and who the hell knows what these parameters should be. So to do that, there are several options you may focus on, you may based on other modelings like FEM analysis, you may do experimental work, and then you get some inputs and outputs data sets and approach the system identification. So automatically parameterize your model to be very, very close to the reality. And of course, one of the advantage of the Simulink is that you may easily model the logic by using the state flow chart, by using MATLAB functions, with commands if, with commands for. So it may be a conditional driven model. It may look easy, but when we're talking about the car model, it is a very complex architecture, and it takes a lot of time to model every element of that model. Moreover, it is in need from time to time to make verification of other variants. So possibly you need several variants of the same model, so another 100 of hours you need spent to model it. So it sounds pretty cool, yeah? So instead of that, you have just one app which do all these mechanical of these, let's say, simply steps for you. And it is just one app in which you may set your parameters, you may choose your powertrain variant, and you will get the model, then you may customize it, and so on and so on. How simple is it? You may see on the next video. So let's start to talk about model generation. So we've got plenty of apps. When you go to the main MATLAB window and to the apps pane, you will get over 100 apps. And then you may choose the Virtual Vehicle Composer app. And in this window, you just create a new car. Choose the type of car, the type of vehicle. Choose the powertrain architecture. You may choose between electric, traditional, hybrid. You may go for fuel cell if you want to. And the model template and the vehicle dynamics, and you are really close to the goal. Then you will get your spreadsheet. In the spreadsheet, you may adapt your parameters. You may even choose them from prepared lists, or you may adapt some other third-party results by using FMI interface to collect it into your model. About motors, you may have the very brief understanding by making the loss plot. You may rescale your model to know what will be the results and set your test scenarios. So from traditional one, you may choose one drive cycle which will be suitable to your local regulation, or you may go for sine line and make the 3D simulation ready to deploy. Then as you can see, you've got your model. And it is structured, so your plant is already prepared. You may change every of subsystem. You may change any just one algorithm inside, and then generate your test. It is the 3D scenes. Afterwards, you will also get information from the simulation data inspector, which may helps you to produce some insights to make some changes in your real prototype. So as you can see, it may looks the easiest like that. Actually, to be honest, when you're going to the easiest architecture and the easiest dynamics, it takes several minutes to get the full model. And may you ask, is that model real? Is that model really close to the real environment? Fortunately, FEF is a corporation who made the laboratory tests, test all these parameters, so they are pretty close to the benchmarking data. So now you know how you may generate your model. Let's customize it. As I said, you've got your model. And you can see that you will have here the driver commands, you've got controllers, environment, some test generators, and the plant, and the visualization. So even if you have your own vehicle, you may even delete the plant, put your own. If inputs are the same, you are ready to play. Or you may go inside, you may try to change just one algorithm to test it. May this solution will be really challenging to test, but here you'll get full vehicle model, so you may change just one algorithm, test it in the full vehicle. And of course, you may, based on the Simulink, but you are not limited to do that because of some integrated C code, S function, FMUs. You may implement co-simulation with third parties with ease. As I said about spreadsheets, usually these models related to motors, to engines, have the proper set of parameters called lookup tables. These lookup tables are multi-dimensional. So you may generate it automatically by using model-based calibration toolbox. If you got your own spreadsheet, easily you might generate the lookup table suitable to that model. And you may also use Simscape, because Simscape may take some more insights about your model. So you may go more in details. In this case, you may model your tires, you may model the forces between suspension. Now I should play for you the video, but possibly it may not work. But here you have the video. Is there anyone to press play? If not, okay, ja sobie puszczę tylko play. Dobra? Ja ci powiem kiedy zatrzymać, ok?
A great advantage of the multi-body package is that you can actually and graphically see what the car is actually doing. So also the back time is also further reduced too.
Yeah, and similarly, I think you can perform different track simulations or closed loop simulations as well. So yeah, so perfect. This is great, Nicolo. And along with that, this is one thing is that we are having a simulation where you are visualizing this, but at the same time, the data that you need that can also be logged to different sensors which are there in the multi-body. Or if you're using different joints, the joints are having sensors to sense the forces, acceleration, velocity, and other parameters. Perfect. So Nicolo, can we do one more thing? Can we have one closed loop simulation as well, just to have a look into some kind of track simulation?
Yeah, for sure. Apart from open loop maneuvers, we can also perform closed loop maneuvers. In this way, we can perform lap time simulations of the various tracks that Formula Student is composed by. In this case, we are going to perform a simulation of Formula Student Germany Outcross.
Perfect. So this is quite helpful. So with this, we have covered the closed loop simulation, we have covered the open loop simulation, and you also walked us through the whole subsystem, how we have built it. So
Okay, we may stop.
I remember,
We
Nicolo,
may
that
stop
you
the
also
video.
talking about the GGB product as well, what
Or
we did.
we
So
may go further.
would
No?
you mind
No?
going through that?
Możesz zatrzymać, no?
Yeah, for sure.
Poleciał? Dobra, fajnie, dzięki. Okay, so we were talking about customizing your model, and now let's talk about MATLAB project. It is a really nice tool to make your collaboration on higher level, because it is really easy configured with the Git repository. You may, from the MATLAB point of view, have trace all the changes. You may merge your models when it is developed in parallel, and you have from 2.5e release a very nice friend called MATLAB Copilot, and you may ask them magic questions to get such an advisor. How to set that project as a source control? It's really easy. You may see that you may just choose to use source control and just simply add your project to the proper variant of repository. And then you may get some insights what was changed. You may add your commits. When it's already updated, you may add it to the remote repository, which is already exists. Or alternatively, you can simply share it. We choose here a GitHub by inserting your credential. You will get your projects right in the GitHub in a minute. As you can already see. So the last but not least is about the simulation. So how to simulate your model. There are several ways, because you may feel free to customize. You may directly set this scenario from the VVC app. But you are not limited to do that. As you can see, you can adapt here the import and outports. you may adapt here in these imports some structurized command comes from MATLAB script to make several tests just in one script, or you may adapt it to the speed goat machine to make your RCP tests or HILD. And as my colleague Mateusz shows you, this driver command subsystem is really nice because you may go for the game wheel hardware by just selecting one option from the choosing lists, and you're ready to go with play with your model. It is capable by Simulink 3D animation, in which you may stay the weather condition. Also, if you want to set just one car, one typical car, you may do it really quickly, as you can see, to simulate in really engine, or you may, of course, apply these inputs provided by the 3D vehicle with ground following, just getting the outputs from your VVC model. And lastly, why to do 3D simulation? Because you've got many more insights which are not easily to get from your real objects. So in that example, you may see that you will have all the forces coming from tires, velocities, and so on. So, what's next? Okay. So next is a summary. So as I said, VVC may be useful to quickly generate your model, which is fully configurable and customizable. Then you may make all your changes. Model is in the MATLAB project, so easily configured with your GitHub repository. And of course, in the last, you may simulate it in the 3D environment, and all these capabilities are inside the MathWorks tools, which are already available in campus-wide licenses. So in the last, we as ONT, we are companies covering whole Poland. So if you came from Poland, we've got specialized trainers which leading trainings for in Poland LFT. And these training hours are authorized by MathWorks, so you will grab the certificate made by MathWorks by coming for our trainings. If you are interested, there is a Piotr who is your, let's say, leading manager, and he may help you in every issues. So thank you so much. I encourage you to go to our social medias. We try to add there some novel insights which are going to be developed by MathWorks. So with these, they're available there in the Instagram, in LinkedIn, and so on. Okay, so if you have some questions, feel free to come here. I give you my microphone and we may talk. if not, thank you so much, and see you next year.